Think of a vivid childhood memory from a rural morning. You can likely see the vibrant green of the plants and watch the heavy morning dew drip from the edge of a banana leaf. But there is a gap in how we share these moments. Every specific, textured detail lives entirely in isolation inside your own mind. If you describe your grandmother's house, a listener might picture a generic building. Language is too imprecise to communicate the ambient temperature, the angle of the light, or the exact coarse texture. To make someone else truly feel your nostalgia, you have to bridge the gap between subjective emotion and objective physical reality. The Golden Courtyard Project attempts to build that bridge by translating memories into a shared space. The project replaces poetic descriptions with the technical language of modern cinematography and AI rendering. It utilizes a process called translation logic, which converts an emotional script into hard, computable data. By using this specific prompting architecture, nostalgia becomes a physical landscape that can be meticulously engineered. The first step of translation logic is constructing the physical world of Ajji, the grandmother's house. The system requires specific geometry, mapping the exact placement of red terracotta tiles and a central open courtyard to create a structural wireframe. Then variables for atmospheric mist and soft golden sunlight calculate how light casts long shadows. These lighting physics trigger the brain's unconscious recognition of early morning by mimicking the way light actually scatters through dust and moisture. A virtual environment only evokes nostalgia when its underlying architectural and atmospheric physics are perfectly defined. Memory is not a wide-angle lens. It is highly selective, focusing on specific actions while blurring everything else. In the scene of a grandmother churning butter, the technical requirement for volumetric God rays isolates the physical action, pulling the viewer's attention exactly where the child's memory would be. When the focus shifts to a child running, the memory relies on the tactile surface of the floor, specifically the polished, freshly applied red oxide finish. To capture the energy of that moment, a Steadicam tracking shot is used to mimic the kinetic point of view of a child moving. A shallow depth of field intentionally blurs the background, replicating the way a child's brain prioritizes the colorful spinning pinwheel over its surroundings. Managing virtual lenses and depth of field replicates the physiological way we perceive a scene, allowing us to simulate the selective focus of a child's mind. This technical simulation eventually addresses the hardest senses to translate visually: taste and smell. Capturing the texture of filter coffee requires extreme technical specifications, using 8K resolution to define the bubbles and the specific brass material of the tumbler and debara. The system's prompt demands perfect liquid physics and 120 frames per second slow motion to accurately render the steam as it rises. Because the human brain associates high-fidelity visual patterns with physical experiences, observing these fluid dynamics triggers cross-modal retrieval, summoning the associated smell of the coffee and warmth. This absolute technical precision allows a stranger to inhabit a tactile memory that was previously entirely inaccessible to them. When we zoom out from these individual sensory data points, we see the completed sequence as a holistic digital achievement. This process converts individuals' subjective history into a technical dataset that anyone can experience. Instead of passively remembering a lost 1990s childhood, this method provides an active way to preserve cultural heritage. We now possess the architectural blueprint to capture our most fleeting moments and render them into a shared, permanent reality.